This video, I'm going to talk about reflection over x-axis and the y-axis. So we're going to start with the parent function. So let y equal x be a parent function of type parent. Then our first type is going to be this. So y equal to c times x. So you see y values are multiplied by c. Now it will depend on, of course, the c has to be negative in this case, right? So c is smaller than 0. So c is a number, okay, and f of x is a y value. So if c is outside, basically, it's a coefficient of f, then this will mean that, you know, we're reflecting the graph over the x-axis. So this is a reflection over x-axis. I will give you an examples of it in a little bit. So the second type is when the c is inside. C is inside, so c times x. C is negative, of course, in this case. So therefore, we will have, if x is multiplied by this negative number, if x is multiplied by a negative number, then we have reflection over y-axis. So I'll formulate this better over here. So let me write it like this. So here is the story. So if you take a point, any random point, okay, if xy is a point, parent function, the parent function, then, okay, now x does not change, but y becomes negative, right? And if y is changing the sign, right, then this is reflection, the reflection over the y-axis. So if this is on the parent function, then x negative y is a point on this function. Okay, y equal negative. Okay, so negative is gonna, because this negative is gonna make the y values negative. And then you can, the other one is, again, if xy is a point on the parent function, the point on the parent function, then x is going to change the sign. So it's going to be negative xy. Okay, and this is a point. This is a point on this function, y equal f minus x. So the sign of x is changing in this case. Okay, so let's look at some examples. First example is this. So if I take, let's say, f of x equals negative x squared. See, x squared is a parent function, and this negative is outside, right? So since it's outside, so let me just remind you the parent function x squared, this parabola. Okay, now I'm going to reflect this. So it's going to be reflected over this line, right? Over this line. Over this line. Therefore, it will move here. It will sort of like be flipped over the line. You see it's sort of like flipped over this line. Because y's are, so you have xy here. Now you translate those points to x negative y. X didn't change. X are still the same point, but all the y values becomes negative, as you see, because it's, you know, you flip it. Okay. All right. So this is the formulation of the point. So you can kind of play with any point using this formulation here. Okay, let's try another example. So let's say I have this function, square root of negative x. We know the parent function is square root of x here, right? Which is this guy. Now, because the negative sign is right in front of x, right? That means the x are going to change the sign. So therefore, any point on the parent function xy will be translated to this point. negative xy, right? X is changing sign, y is not changing. Y is not changing the sign. So therefore, this is going to be translated to this. So x are the same. X are the same, but the y's, I'm sorry, y's are the same, but the y's are changing the sign. See, x's here are all positive. Now x's are all going to be negative. So it will be this way. Okay, so all here are negative, but the y's are not changing. Okay, so let's do this. So here is another example. Say I have this y equal to negative absolute value of x minus 1 plus 2. So you see, I kind of mix it because so far we have the 3 type, right? This 2 transformation and then the reflection as well. So if I put an order on the operation, so I'm going to do inside first. So I'm going to put that down here. So first I'm going to go right 1, okay? Because subtracting 1 means you go right 1. And then I will do multiplication next. So multiplication, so this is like a negative 1 is a coefficient. So I did this first, and then I'm doing multiplication. That's what orbital operation is. And that's a reflection. So I will do reflection next, reflection over x-axis. And then I will do plus 2. And plus 2 just means that up 2. So I have 3 operations to do. So first, let me put the parent function, which is an absolute value function. So that's this. And next, I go right 1. So here is right 1. Next, I will reflect this over the x-axis. Here is 1. So I reflect it. I flip it basically. So it's still 1 right there. And then I add 2. So if I add 2, then I'm just going to, this is 1. I'm going to go 1, 2. At this point now. It's like this. Okay. But if you want to formulate it with the points, so this last one is y equal to negative x minus 1. Okay. I kind of do it each step like this. So first I did minus 1, and then I did minus x minus 1, and then I did the final one. But if I formulate this with the random points, I would just do this. So I pick a random point. What did I do first? First I add 1 to the x values, right? Because I go to the right, so x plus 1. And then I multiply the y values by negative, right? Negative y. And then I add 2 to the y values. So it's this. So this is a formulation of the point. Pick any point on the parent function and then use it. You can generate any point on the translated function. So it's really that simple construction, basically.